In a previous video, we started studying the definitions in the first lesson in Algebra I. We looked at the first 10 articles. We learned about quantities, the two different kinds of quantities. We learned about how the two different kinds of quantities are measured. We learned about unit and number, and then the two different kinds of numbers, abstract numbers and concrete numbers. One of the things we looked at, the very first article, in fact, in the first lesson, was that in algebra, we represent quantities with letters of the alphabet. And we said, that's strange, that's different from arithmetic. And I said, we'll talk about that more later on. Well, as we get down to Article 11, you'll see that we're going to get back to this discussion of representing quantities, not just with numbers, as we did in arithmetic, but also with letters. So we'll continue to study and we'll continue to pay attention for what we can learn about how we represent quantities with letters in algebra. Let's begin in this video with Article 11. We read, in algebraic computations, letters are considered the representatives of numbers. In algebraic computations, that means in solving algebraic problems. In algebraic computations, letters are considered representatives of numbers. Letters are considered representatives of numbers. And I want you to keep that word representative in mind as we study the next few articles. Why are we using letters in a math class? Why are we using letters as representatives of numbers? Why not just use numbers? Why are we using letters in algebra? We'll get an answer to that question in just a minute. So in Article 11, we learn in algebraic computations, letters are considered the representatives of numbers. Let's go on to Article 12. There are two kinds of questions in algebra. Two kinds of questions in algebra. Theorems and problems. And we can see these two kinds described in Articles 13 and 14. There are two kinds of questions in algebra, theorems and problems. Two kinds of questions in algebra. First, the theorem. In a theorem, it is required to demonstrate some relation or property of numbers. And to demonstrate means to prove. In a theorem, we're asked to prove something to be true. In a theorem, it is required to demonstrate some relation or property of numbers or abstract quantities. So if we need to prove a relation between quantities or a property of numbers, that type of question is called a theorem. In theorems, we need to prove something. Remember the key there. A theorem asks us to demonstrate something. The second kind of question in algebra is a problem. In a problem, it is required to find the value of some unknown quantity. In a problem, it's required to find the value of some unknown quantity. So in a theorem, it's required to demonstrate something. In a problem, we're required to find the value of something. So see the difference between theorems and problems. If you're asked to prove something in algebra, it's a theorem. If you're asked to find the value of some quantity in algebra, that's a problem. These are the two different kinds of questions in algebra: theorems and problems. Now, let's look at some of the details here in Article 14, because these are important. In a problem, it's required to find the value of some unknown quantity. In a problem, it's required to find the value of some unknown quantity. How can we possibly find the value of an unknown quantity? We can find the value of an unknown quantity by means of certain given relations existing between that quantity, that unknown quantity, and other quantities which are known. Let's read that again, because I'm sure that was a little confusing. In a problem, it's required to find the value of some unknown quantity. And we do that by using other known quantities. We use quantities that we know to find the value of some quantity that we don't know. We use quantities that we know to find the value of quantities that we don't know. Now, when we think about the fact that we're trying to find the value of unknown quantities in algebra, it makes it easy for us to understand why we use letters as representatives of numbers. We use letters to represent numbers in algebra because some of the numbers are unknown. We don't know the number. We don't know the value of the number. That's the whole question. In the question, we're seeking to know the value of a number. The number is unknown, so we can't represent that value with a number because it's unknown. And so we use a letter to represent the unknown number. And sometimes we use letters to represent known numbers or known quantities. And we'll see how that works later on. But understand, in a problem, we try to find the value of some unknown quantity. And we try to figure out the value by thinking about quantities that are known and how they relate to one another and how they relate to this unknown quantity. Because we're working with unknown quantities, we represent those quantities with letters because the numbers are unknown. So make sure you understand that there are two kinds of questions in algebra: theorems and problems. In the theorem, we demonstrate something. In a problem, we find the value of something. And then understand that the reason why we use letters as representatives of numbers is because quantities can be unknown in algebra, whereas in arithmetic, there are never any unknown quantities. So these are the two kinds of questions in algebra: theorems and problems. Make sure you understand the difference between these two types of questions in algebra. Let's keep going down to Article 15. Here in Article 15, we have the definition of algebra. In Article 1, I told you there was a description that gave us some information about algebra. It said, in algebra, we represent quantities with letters. And I said, that's not the definition of algebra. Here we find the definition of algebra. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. Algebra is a general method. The word general here is important. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. The reason why I say general is important is because algebra is a method. It's a method of solving problems, but it's general because it applies to all different problems and all different theorems, all different questions. In algebra, we learn about relationships and properties of different quantities, and we use this knowledge to answer questions about all different kinds of quantities. So because this method applies to all different kinds of quantities, we call it a general method. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. The letters and signs, we're told, are called symbols. So here we have an introduction to talk about letters and signs that are used in algebra. And if you look down below, the next section, we're going to study these different signs that are used in algebra. But we're going to stop here at Article 15 in this video. And so we've covered Articles 11 through 15. We've learned about the two different kinds of questions in algebra, theorems and problems. You should understand what the differences are. We also got a little bit of information to help us understand why we represent quantities with letters in algebra. And here in Article 15, we have the definition of algebra. Algebra is a general method of solving problems and demonstrating theorems by means of figures, letters, and signs. I hope that's a helpful walk through these 5 articles. If you have any questions about anything in these 5 articles, please get in touch. I'm happy to help. God bless your studies.